Welcome back to my channel. I am Dr. A. Navanita, an Assistant Professor in EC Department, Mahatma Gandhi Institute of Technology, Hyderabad. So here I am going to discuss an important topic which is very important for the VLSI engineers and who is planning in the VLSI industry for the professionals. It is a very important topic. That topic is nothing but FPGA and ASIC. Okay, so here in this one recently we have seen that our Prime Minister PM Modi has launched the first 32-bit Vikram processor which is made by India. So here this is because there is a lot of demand, then $1 billion of industry profit is getting from this industry. There is a lot of scope is there for the professionals and those who are planning to start up in the VLSI industry. There is a very much bright future will be there. So here in this one because of the demand in that I have chosen this topic. So I think I will do justice for what I have done, what I am going to discuss that. Okay, so here in this one before coming to the difference between FPGA and ASIC, so we should know what is a FPGA and what is its purpose. F stands for here field program, P stands for programmable, G stands for gate and A stands for array. So FPGA stands for field programmable gate array. So what is the importance of this field programmable gate array? So the importance of field programmable gate array is nothing but whatever the logic of the circuit, logic of the digital circuit you want, that digital circuit logic through hardware means you can check using this hardware circuits which is in the form of IC. Example, you can take Spartan 3, 6, Vertex and Vertex 7, Arctic 7, so Vertex 3, all these are the different types of FPGAs where you can check any logic of the circuit like your AND gate, OR gate, multiplexer, demultiplexer, CPUs, memory. Any logic of the circuit will be tested on this hardware. How they are going to give by giving the inputs and outputs. First what they will do, they will write, think you want to test the logic of AND gate. For that logic of the AND gate will be written in the like this, a program will be written. Here an example of some think we have written a program for some XOR gate, isn't it? So here whatever the program which I have written in the using this XOR gate, that is nothing but your full adder. A program will be written in this one. After writing the program, that program will be converted into binary bits of program. After converting into binary bit of program, that binary bit of program, this will be done using the software tool, either using Xilinx ISC or Vivado can be used. After conversion of the binary bit of program in the software tool, that program is going to be stored in the one hardware block that is nothing but RAM. Okay, RAM is a hardware device which is used to store the binary bit program which you have written the program either in the Verilog, VHDL or system Verilog. Okay, so whatever the logic of the circuit you want to implement, that logic of circuit will be implemented using hardware blocks which is present in the FPGA, that is nothing but configurable logic blocks. And to give the inputs and outputs, here input output blocks are used. Think you have written program for 2 input AND gate. So 2 inputs will be given to the switches which is present in the input block and output is checked on, one output is checked using the LED which is present on the output block. So input output blocks are used for giving the inputs and output and checking the logic of the circuit whichever you have designed. And configurable logic blocks are used for testing the logic of your to implement the logic of the circuit. And here RAM is used for what? RAM is used for storing the binary bit of program which you have written for logic of the program. So whatever the program is written, this logic blocks will be taking that program. According to the program written, this logic hardware blocks will be implementing the logic. After implementing the logic, whatever the input you give, it is going to give the output. If you go for 2 input AND gate, 2 inputs means 4 combinations will be there, 0 0 0 1 1 0 1 1. So here 0 means switch will be off condition and 1 means switch will be in on condition. So 0 1 one switch will be off and other switch will be on. 0 1 means AND gate you will get 0 only, LED will be shown in the off condition. If it is 1 1 means both switches will be in on condition and your LED should glow showing the output, it is nothing but logic 1. Okay, this is about your FPGA. So next, how that process is going to be done, that I am going to tell here. So here whatever the design which we are going to discuss, nothing but it comes in the VLSI design, front end design. Okay, first whatever the logic of the circuit you want, that logic of the circuit, I think you are working in the Intel company. In the Intel company, one DRDO customer has come to you and they have said that they want the power of 1 milliwatt and a giga and speed 1 gigahertz and area some 1 micrometer, like that. So they will collect the specification from the customer, that company. After collecting the specification for the circuit, think they are developing some half adder. For that half adder circuit, this is a specification they have given, that is 1 milliwatt, 1 gigahertz and 1 micrometer. For that one, so after taking the specification, that company from the customer, what they will do, they will analyze the circuit of the half adder in terms of block diagrams, truth table for the given, and what is the logic gate circuit it is going to have, for given inputs what is the output it is going to have. Everything will be analyzed on the paper. Group of engineers will analyze the design of the circuit. Once the design of the logic of the circuit is over, then they will write the program, HDL program, that is hardware description language program will be written using VHDL or Verilog or system Verilog. They can make use of writing the program for a half adder. Once the logic of the program is over, then what they will do, they will whatever the logic, once you write the program, what will do, any programming language, we will convert that program, whatever the program is there, that you are going to check, you are going to save the program, isn't it? After that, you are going to compile the program, whether error is there or not in the syntax of the program which you have written. If it is error free, then they go for testing for simulation. So here in the simulation, what they will do, for the given input, what output you are going to get it. For a given input means what, for A and B, think you are written for the AND gate, A, B will be your input, C will be your output. For 0, 0, what is output, 0, 1, what is output, 1, 0, what output, 1, 1, what output. So if you take here, in the waveform also, there also in the tool you are going to check with the waveforms only. This is low line means logic 0 and this is also logic 0. So 0, 0, what output you are going to get. For 1, above line means 1, 1, 1, what you are going to get, 0, 1, what you are going to get, for 1, 0, what you are going to get. So this function, whatever the testing you do for a given input, what output you are going to get, that is set to be the simulation, functional simulation. After that, they go for synthesis. What do you mean by synthesis in the VLSI process? In the front end design, whatever the program you have written, if that program is going to be converted into gate level circuit, that is said to be the synthesis. After synthesis, again they are going to check this is the one gate level circuit where they have got it for the program written. For this gate level circuit, whatever the inputs are there, for the given inputs, what output they are going to get, that inputs and output will be checked, that is said to be the post synthesis simulation. Okay. Next, what they are going to do, whatever the gate level circuit they got it here, that is synthesis output, they are going to implement on the one hardware circuit, that is nothing but IC. That hardware circuit IC we are calling as FPGA. Think you are making use of some Spartan 3 FPGA. So this is a development board where our Spartan 3 FPGA is present. On this development board only, you are going to have inputs, outputs, switches, input switches and output LEDs you are going to have, which is given by the manufacturer, and the middle one you can see one IC. This IC represents whichever the FPGA which we are going to take. Here example I am taking as a Spartan 3 FPGA. Okay, so here whatever the gate level circuit is there, this gate level circuit, already we have seen that in the FPGA you are going to have what, you are going to have configurable logic blocks. So your program for the whatever you have written a hardware half adder, how many configurable logic blocks it is going to take, that will be studied in the implementation. So in the implementation will tell you the hardware circuit program which you have written, whatever the program you have written for the hardware circuit in the FPGA, how much hardware it is taking, how many configurable logic blocks it is taking, input output blocks it is taking. Okay, that will be done in the implementation part. After the implementation part, again they are going to do the simulation for given input what output you are going to get, that is said to be the timing simulation. Next, whatever the program you have written, that program will be converted into binary bit program. This binary bit program is made to put on the FPGA that is going to be, that is present in your development board. So once the program is, binary bit program is dumped in the FPGA already you have seen you are going to have RAM memory. So that binary bit of RAM memory which is present in the FPGA will be storing the binary bit program. So here once the program is dumped on this, a indication will be shown that program is dumped. Once program is done on this development board, you are going to check for the given input what output you are going to get. So how you are going to check here? You are going to switches you are going to on and off. Two switches will be, if you are going for AND gate, two switches will be used for input and one LED will be used as output. So here when a switch is off, it shows logic 0, when switch is on, it tells is a logic 1. Okay, so in this way it is 0 0 0 1 1 0 1 1 you are going to check. If it is 1 1, your LED should glow output. If it is 0 0 AND gate, your LED should be off. In that way on this board you are going to check the logic of the circuit. So any logic of circuit, digital logic circuit you can check. You can check AND gate, OR gate, multiplexer, demultiplexer, encoders, decoders, counters, CPUs, memories, any logic of the circuit can be implemented on the FPGA. What is the changes you have to do on this FPGA? Only FPGA will be the same. What you need to change for a different logic of the circuit, only the code which you have written, only that has to be changed. Okay. So next one is we will get into the difference between FPGA and ASIC. So what is the full form? What is the full form of the ASIC? ASIC stands for Application Specific Integrated Circuit. Okay. FPGA stands for what? Field Programmable Gate Array. What do you mean by Field Programmable Gate Array? Any logic of the circuit you are testing with the help of the program, and that program you are implementing an array of the gate on in the place where you are working, that is a field. That's why this circuit is said to be the field programmable gate array. Okay, what do you mean by application specific integrated circuit? So specific thing, you have developed one hardware circuit. That hardware circuit is only used for a robot which is doing some customer service. So that the circuit, hardware circuit which you have developed in the form of IC to do only service for the customer service which is used in the robot, that specialized circuit for one specific purpose we are calling as a application specific integrated circuit. You can take anything. I have given one example, any IC circuit which is used for only one purpose, for specific purpose, that is robo. I have given example. That kind of circuits we call it application specific integrated circuits. So whenever you go for application specific integrated circuit, here what you are going to do, you are going to write the code which I have told you, either Verilog or VHDL system Verilog. After that what you are going to do, whatever the program is written, that will be converted into gate level circuit. After the gate level circuit, the program is converted into binary bit program. Next it is made to put it on the FPGA. So here when you go for ASICs, after converting into the gate level circuit, here only they don't convert into binary bit. Here after the gate level circuit, they will convert each gate into transistor level circuit. After that each transistor is going to replace with a semiconductor circuit. That semiconductor circuit we call it as a layout. That layout is made into fabrication. Okay, so here in this one what they are going to do, design all the way from writing the program to the physical layout, which I told you. Layout is nothing but a circuit in the semiconductor level, which of the circuit you are developing. So next in this one what you are going to do in the FPGA, you are not going to do any semiconductor level of circuit here. Here what we have done in the FPGA, whatever the code you have written, that converted into gate level circuit, it was converted into binary bit and you are made to put it in the FPGA, isn't it? So here in this then, here when we go for FPGA, whatever the no conversion, no semiconductor level of circuit will be there. Here what the code will be ended with the binary bit of program. That binary bit program you are going to put on your FPGA device. So here design ends with the bit stream, that is binary bit program used to configure a device. That means whatever the binary bit program you have developed, that binary bit program which is present in the FPGA is going to implement the logic. Configure means implementing the logic on the device. Okay, so what you are going to do here, whatever the semiconductor level circuit layout is there, it is used in the fabrication industry to fabricate that circuit in the form of IC. Design must be sent for fabrication industry, so it will be very costly, expensive, and it takes design for ASIC takes nearly 1 or 2 years also. So it is a very time consuming in the semiconductor foundry. But whenever we go for FPGAs, whatever the logic of the circuit you want, every logic of the circuit will be away from your semiconductor fabrication industry, and that logic of circuit, everything you are going to implement with the help of a program, either Verilog or VHDL or a system Verilog. So here in this one, that programs is going to be implemented with only one FPGA. So it is a designer can be implement any logic of the circuit on the FPGA only by changing the software program, that is either using Verilog or VHDL. Next, what you are going to do in the when you go for FPGAs, only you can check the functionality, but you cannot change the performance of the circuit, like power you cannot reduce, speed you cannot increase, you cannot reduce the area. So whenever you any designer design the circuit, one thing they have to remember that they need to have the low power, high speed, low area. That can be obtained only when you make the circuit in the form of ASICs. So high performance means low power, high speed, low area. This can be obtained when you fabricate the circuit in the form of semiconductor. Here only it is used for checking the functionality of the circuit. It is like a prototype model, but not the actual model of the circuit which you are going to do it. Okay. Next one is nothing but ASICs. I told you, as I told you, it is going to have low power. And because here everything is deal with the software, it is going to have the low development cost, your FPGA. Next one here, because everything you are dealing already ready-made FPGAs are there, or you are developing the program and converting to binary bit, and you are just checking on that. So it is very short time within you can release in the market whatever the design of the circuit, prototype model of circuit you can release in a short time. Next, here if you go for this ASIC, once a circuit is made in the form of IC, if it is made in the millions, it will be in the low cost. Okay. And you can reconfigurable means what? Any program you can reprogram. You can, once you have written once you have written the program for and dumped on FPGA means you can go for CPU. CPU program you can go. You can go for say a program for memory. Any program logic can be implemented on this one FPGA. That is reconfigurability means how many times you want you want to implement the logic, that many times you can do the program of the circuit as the designer wants. That is the concept of reconfigurability. I think I have given a lot of information regarding the FPGAs and ASICs, isn't it? So here once again just have a look at here. ASIC stands for application specific integrated circuit and FPGA stands for field programmable gate array. I think if you have still any doubts, you can put a comment in the comment section, and click the button, subscribe it, and if you want any changes in my video, you can have a comment and tell me what improvement has to be done. So if you like my video, subscribe it. Thank you once again.